So next, suppose we're asked to find the horizontal asymptotes of r of x equals 4x squared plus 6 over 2x squared minus 3x. Now the degree of the numerator and the denominator are both 2, so we can't use that trick that we talked about last time. But what we can do is attempt polynomial long division. So let's try to divide 2x squared minus 3x into 4x squared plus 0x, I'm just using a placeholder there so I don't forget that it's there, plus 6. So now what do I need to multiply 2x squared by to get 4x squared? Just 2. And when I multiply, I get 4x squared minus 6x. And now I'll subtract. I'm never going to forget to subtract. And this will give me 6x plus 6, which is my remainder, because that has degree 1 lower than the degree of my divisor. So this rational function equals 2 plus 6x plus 6 over 2x squared minus 3x. Now, we know what happens to this second piece as x goes to infinity, right? So let's go ahead and take the limit as x goes to infinity of 4x squared plus 6 over 2x squared minus 3x. That's the expression of my function. We already said that this guy equals a limit as x goes to infinity of 2 plus 6x plus 6 over 2x squared minus 3x. And now we said that this guy already is going to 0. We showed that last time because the degree of the numerator is 1, the degree of the denominator is 2. So this whole thing is just going to 2 plus 0, which equals 2. So my horizontal asymptote is the equation of the line, which is y equals 2. So there's my answer. Now if you notice, looking back at the rational function we started with, that is exactly 4 divided by 2. Those are our leading coefficients, and when we divide them, we get exactly the number 2, which is where our horizontal asymptote happened to be. That's not a surprise, so let's go ahead and sum that up. If r of x is a rational function, we need it to be a rational function for this to even make sense, and the degree of the numerator is equal to the degree of the denominator, then the quotient of the leading coefficients gives us our asymptote. And that's going to work whenever the degrees are equal. Next, we'll talk about what happens when the degree of the numerator is 1 higher than the degree of the denominator.